let's have a look at some trig functions. So let's start off with the function y is equals to sine x. All right, so the function y is equals to sine x. So your x-axis, which is your inputs, that's measured in radians. All right, then your y-axis is your output. And we're going to go from 1 to -1. Right, so if you type into your calculator, the sine of 0 is 0. The sine of pi over 2, which is 90 degrees, is 1. The sine of pi is 0. The sine of 3 pi over 2 is -1. The sine of 2 pi is 0. So what happens is, when you calculate the sine function, you draw it, it creates this wave-looking feature. And that wave-looking feature continues on and on and on. So it continues on like that and on forever. We call that periodic. It's a periodic function in terms of it repeats. And when you're looking at periodic functions, there's two things you care about. You care about the period and the range. So the period is the length of one full repetition, and the range has got to do with the y values. The range is all about the difference from the lowest values to the highest values. So in this particular one you're looking at, you can see that the range in this graph is from -1 to 1, and the period, the length of one full repetition, is 2 pi. Okay, so that's the sine function. That's the function y is equals to sine x. What about the cos function? Let's have a look at that as well. So now we're going to look at y is equals to cos x. So same again, I'll start off the same way. I've got my two x's. I've got my 0, pi over 2, pi, 3 pi over 2, 2 pi, then we move on to 3 pi, then on to 4 pi. Okay, so this is the cos x function. So then the cos of 0 is 1, the cos of pi over 2 is 0, the cos of pi is -1, 3 pi over 2 is 0, and the cos of 2 pi is 1. So this cos function, it's still a wave, but it's not exactly the same as the previous one, as the sine function. It's very similar though. All right, so there's your cos function, another periodic function. All right, the period of the cos function, the length of one full repetition, the period is still 2 pi. All right, and you can see the range as well is still from -1 to 1. So the range and the period are still the same. The range is from -1 to 1, and the period is 2 pi. So for both the cos function and the sine function, the period and the range are the same. The difference is where it starts. The cos function, because the cos of 0 is 1, so the cos function starts by cutting the vertical axis, the y-axis, at its highest point, whereas the sine function cuts through the y-axis, through the origin, through 0, 0. So that's the main difference. Apart from that, they're quite similar. All right, apart from that, they're quite similar. So then what we have to do is we have to move on to functions of the format. So if we want to deal with a function of the format b sine cx. So basically put in numbers now. So for example, what if I had the function, 3 sine 2x? How would that look? Well, what we need to understand is that the range will always be from -b to b, whatever that number is. And the period will always be 2 pi divided by the number c, whatever that number is. So that is true for all functions of the form b sine cx, and also, and also of the form b cos cx. All right, so that will always be true. So let's just have a look. So as you can see, the range is affected by b and the period is affected by c. So what you have here, this is the graph of sine x, right? 1 sine 1x. So let's change the value of b. All right, so as I change the value of b, you can see what happens. As I increase b, it increases the range. It doesn't affect the period. So the bigger value of b, the bigger the range is. All right, and then if I increase c, by increasing c, you're actually decreasing the period. You're making the period smaller and smaller. All right, because the period is 2 pi divided by c. So the bigger the value of c, the smaller the period. So c affects the period, and that's the sine function. The exact same thing is true with the cos function. So by changing b, you're changing the range, and by changing c, you're changing the period. Okay, so if I wanted to graph the function 3 sine 2x, what would I need to understand? I would need to understand, first of all, that the range in this case would be from -3 to 3, and the period in this case would be 2 pi divided by c, which is 2, so that's pi. So the range would be from -3 to 3, and the period would be pi. So if I wanted to draw a rough sketch of it, right, this is for my rough sketch, so there's my y-axis, there's my x-axis. It's a sine function, so it goes through the origin, so I know it will look like that, and so on, and so on, and we'll continue on. I know that the range is from -3 to 3, so up here that must be 3, and down here that must be -3. And I know that the period length is pi, so the length of one full repetition is pi, so that's pi right there, that's one full repetition, so therefore that would be pi over 2. And so on. So that would be a rough sketch. Obviously, if I wanted to be a little bit more accurate, I can use the GeoGebra here to show you. So 3 sine 2x. So once again, we know that the period is going to be, the range is going to be from -3 to 3, and the period is going to be pi. So there, that's what 3 sine 2x looks like. So you can see that the range is from -3 to 3, and the period, the length of one full repetition, so up, down, and back up, the period is pi. So understanding the relationship between the period and the range and the values of b and c, that's pretty much all you need to understand. And also understand the difference between the cos function and the sine function, in terms of the cos function cuts the y-axis at its highest point, whereas the sine function cuts the y-axis through the origin. Once you understand all of that and the importance of b and c, you pretty much understand everything you need to know about the trigonometric functions. There's one addition you may need to understand, and that would be if the function was of the format a plus b sine cx. So if you just add a number to the function. Now this isn't just for trig functions. If you have any function, no matter what the function looks like, so you just have f of x equals whatever, it might, let's say it's a cubic function, it might look like that. If you add a to it, so if it's a plus that same whatever, that moves the function up by a. So the function will just move up the page by a value of a. So for example, if this right here is my function b sine cx, right? If that's what that is, well then what would my function a plus b sine cx look like? Well, it would just, whatever the value of a is, it would move it up by that much. So let's say whatever the value of a is, it would move the function up by that much. So, it would just be the same function, just higher up the page if a is positive, or lower down the page if a is negative. So by looking at that, you can see that if you add a number in front of the function, it only affects the range. It moves the range up. It doesn't affect the period. So what would the period and the range be in that case? Well, the period hasn't been affected. So the period would still be 2 pi divided by c. It's the range that's affected. Remember, the range is typically from -b to b. But if you add a to the function, you just have to add a to the range. That's all you have to do. So it's that simple. All right. So as I said, typically most functions will be of this format, which is b sine cx, where the range is from -b to b and the period is 2 pi over c. If they add a number to the function a plus b sine, that just affects the range. It just adds to the range. It does not affect the period. It just moves the function up by whatever value a is. And if a is negative, therefore it would move the function down.